Okay, we're going to do problem 23. And the problem reads, when the three blocks in figure 6-29 are released from rest, they accelerate with a magnitude of 0.500 meters per second squared. Block 1 has a mass of m, block 2 has a mass of 2m, and block 3 has a mass of also 2m. What is the coefficient of kinetic friction between block 2 and the table? Okay, so I'm going to start off by drawing the situation that I just described in the book. So it's kind of complicated. We have three blocks. It's just an unknown mass, but we know it's all the same mass, and two of the blocks are double the first block, right? So block 2 is sitting on the table, the other two are hanging. So let's list the information that was given. We have the acceleration. And then we have the kinetic coefficient of friction is what we're looking for. All right, so we have that listed here. And then we just want to look at, as always, first kind of a free body diagram of what we're doing here. So we're going to look at block number 2, and we're going to say that there's a tension pulling on both sides of it, right? So we're just going to label that T1 and T2 because they go to block 1. Well, I guess it doesn't matter. So we're going to say that the direction that it's being pulled in, because the right side is heavier, that's going to be moving to the right. And so we're going to have to say that the motion's to the right, therefore the friction is acting to the left. And we're going to write out our formula that we learned for friction. So the force of friction equals mu times the normal force. And remember, we're just looking for the coefficient mu sub k. So we want to figure out what the normal force is. So let's draw a free body diagram for also box 2, but in the y direction. So you have the normal force acting perpendicular to the surface. And then we have, of course, mg acting downwards. The actual mass is 2m, so it's just 2mg. Now we know that the block isn't moving up or down. It's only moving left and right in the x-axis. So Fn must equal 2mg. So those are the y components. Now we want to still figure out what the normal force is over here. So we just figured that out. So we're going to put that in. It's just mu k times 2mg. And we know our acceleration. We don't know T1 and we don't know T2. So let's try to use, again, Newton's second law to try to figure out what the total equation is, just summing up the forces. So let's go ahead and write it out. So we're going to have T2 minus T1 because it's in the opposite direction. That's just the negative signs we're choosing, so they have to all be consistent. And then we are going to subtract that from the coefficient of kinetic friction times 2mg, which was our force. And then that's going to equal the other side of the equation, which is the acceleration times the mass. So you have to have 2 times the mass. And then we have the acceleration in the x direction up here. So we know that piece also. So now we look at this equation, we look at, like, what do we have here? We don't know these m's. We don't know the mu. We do know g, but we also don't know tension 1 and tension 2. So we're missing a bunch of variables, so we can't solve this thing as it is, right? So what we're going to have to do is start looking for more equations, right? We have too many unknowns. We only have one equation, so we're going to need more equations. So let's go ahead and look at the box number 1 on the left-hand side. And again, we'll draw our coordinate system out. So this one's only being acted upon in the y-axis, so we're going to look at the y-axis. We want to add the tension. Make sure the tension is consistent with the tension we draw from box 2, so it's still T1. And then, of course, you still have mass times gravity acting on this thing. So we're going to sum up the forces. Same deal, Newton's second law. Again, we want to watch the negative signs and be consistent so that they are, it works in conjunction with the second box. So again, we have the acceleration, and that acceleration is the same acceleration we know that's going to be acting on the second box that we just solved for. So we're going to write this out, and T1 is minus mg, and then you're going to have it equal the mass and times a positive acceleration. So just keep in mind we've chosen the acceleration to be positive in this direction. So just solving for T1, you have mass, and then you can pull it out, and it will just be the gravity plus the acceleration. So now we solve for T1, so we have now a piece of information for that original equation that we wrote. So let's go ahead and look at the third box so we can get the other pieces of information. So again, free body diagram. Now we're going to start with tension 2 acting upwards, and then we're going to have, of course, 2 times the mass times gravity pulling downwards. And then again, we have the acceleration acting upon it. So this time it's going to be going in the opposite direction, so we're going to want to make it a negative acceleration this time, and it's still multiplied by the 2 times the mass, right? So opposite direction, opposite sign. This one's moving down. Box 1 is moving up, so it's positive A. And again, this is all convention. You have chosen this coordinate system, so therefore you apply the negatives as you choose the coordinate system. So we start to write the summation of the forces. So we have tension 2 minus 2 times mg, and then that equals the mass times the acceleration, which is 2m times a. Solve for T2. So we'll just move things around here algebraically and solve for it. So now we can see that the difference between the second one and the T1 equation is now we have a G plus A and a G minus A, and double the mass, of course. But now we've solved for T2, so T2 can go back into the original equation, right? So if we go ahead and start to write this out and fill in the blanks, so to speak, we have our equation of T2, and now that's minus the equation that we made for T1, and then we're going to have minus the coefficient of kinetic friction times 2mg, and then that's going to equal 2m times the acceleration. So we go ahead and look at these, and voila, all the masses disappear, so we don't even need that piece of information anymore, right? It's just gone. They all cancel out. You have a mass in every piece of the equation, so they all cancel out. So rewriting this and distributing the 2, we'll distribute this negative sign here, and then you have the coefficient of friction again, and 2g, and this will just equal 2a. So we still don't know what the coefficient of kinetic friction is, so that's what we're going to be looking for. And then writing this out, you're going to get these pieces. And so you can you could also sum up all the appropriate G's and the appropriate A's, and then we're going to divide the total on the left-hand side by 2g, of course. So solving for mu sub k, should get g minus 5a, and then that's going to be divided by 2g. So again, we have the acceleration, we have gravity, so we can start filling in numbers. And then when you have gravity, you got to be careful here. It equals 9.8 meters per second squared, but don't arbitrarily add the negative sign, right? We set this up with the coordinate system that we made, so the negatives are already set. So don't add randomly a negative sign to gravity. And then when you solve for this, then it should be 0.3724. And again, it's a coefficient of friction, so it's unitless. So